We're going to look at a whisker plot, which is a really efficient and effective way of lining out significant points on a data set. So where you have this plot here, you can play around with it, change your data set, pick something different. You can change your spread, come up with different data sets, but we're going to use this one here. So two of the main points in a data set are the minimum and the maximum, and that's given by these endpoints of your plot. So this all the way on the left is your minimum. This is the smallest value in the entire data set. And in this case, it's kind of hard to tell on the scale of this x-axis, but it's somewhere around maybe 13, and it tells you over here it's 12.78. And over here is your maximum. This is the largest number in the data set. So that's maybe 117, 116, and it tells you over here it's actually 115.6. The range of a data set is simply the range that it spans. So it's just your maximum minus your minimum. So in this case, it's 102.8. But essentially, to find the range, what you're going to do is just look at this maximum number, look at this minimum number, and subtract. Now, if we wanted to talk about other significant points in your data set, we could talk about the first quartile, which is represented by this line right here. So this line, the left side of the box on the whisker plot, is your first quartile. That means 25% of the data is to the left of this line, and 75% is to the right. Now, notice that doesn't mean it's 25% of the way across the line. It just simply means 25% of all the numbers in your data set are somewhere in this range, and 75% are somewhere in this range. We can look at the third quartile, which is the other side of the box. That's over on the right side, so it's this line right here. And in this case, it's 72.65, and it's kind of hard to tell exactly what it is, but you can guesstimate it somewhere around there, and then over here, 72.65, it tells you. So 75% of the data, in this case, is to the left, and 25% is to the right. 25% of the data points are somewhere in this range, 75% are somewhere in this range. Then you can look at your medium, which is the 50th percentile. It's that line that goes right through the middle of the box. 50% of all your numbers lie over here, 50% lie over here. It's the exact middle. If you were to arrange all of your data points in order, increasing to decreasing or decreasing to increasing, this would be the exact middle data point. Lastly, you have your interquartile range, and that's simply the difference between the third quartile and the first quartile. So this middle 50% right here, there's 25% here, 25% here, that leaves 50% in here. So 50% of your data points, the middle 50% of your data set, is in this box. And the interquartile range is like calculating the regular range, but it's just between the first and third quartiles as opposed to the min and the max. So you take your third quartile, 72.65, and your first quartile, 44.77, you subtract, and your interquartile range, at least in this case, is 27.88. So this is a really efficient way to read a data set, to communicate significant points within a data set, the range, the median, first quartile, third quartile, interquartile range. It's a really effective and efficient way. So somebody asks you, hey, what's the median of this data set given this whisker plot? What's the range? You can simply just look and quickly determine what the answer would be.